Hello, this is Dr. Mears, and today we are going to learn about the laws of exponents. You would have received this law of exponent sheet, and if you're not a student of mine, then you can most certainly screenshot it or write it down, whichever you choose. I'm going to run through these relatively quickly, as then we're going to be doing some example. So there's a lot of rules of exponents. Now remember, your exponent is the raised to a power. We have the power, which is going to be in the exponent spot. And then we have what's called the base, and that's usually that bigger number on the bottom, which is why it's called the base. So here's your power, and here's your base, power or exponent. Couple different names. So we could do a couple different things with exponents when we have common bases. So the first rule, product of powers, this is saying x to the m times x to the n. So when these bases are the same number or the same variable, what we can do when we multiply, we write the base down and we simply add the exponents. So let's take a look at this example. We have x to the third times x squared. And so you see we have the same base, x and x, so we write that down, x, and then we add 3 plus 2 is 5. The next is the quotient of powers. So this is when we were multiplying. Now we're going to be dividing. So remember, this is division. So we have x to the m divided by x to the n. And what we do when we see that we have common bases is we're going to subtract the one in the numerator, the exponent in the numerator, from the exponent in the denominator. So this is going to write the base down, and then it's m minus n. Or if this comes out to be, if this difference comes out to be negative, we're going to put it in the denominator, and I will show you that in a minute. Let's do an example. So first, let's do this first example here where we're simply just subtracting the numerator exponent from the denominator. So we have same base, x and x, we're dividing. So this is 7 and 5, so it's going to be, write down x, and then 7 minus 5 is going to give you that 2. Now let's look at this rule here. So here we have 7 over 5. Sometimes if it's put in the denominator, that means that this was negative. So the negative exponent means something. If you have a negative exponent, that means that it's not supposed to be where it is. So this is not supposed to be in the denominator, so we're really moving it up to the numerator, so we flip it. And vice versa. If we had x negative 2 here, what would happen is this was in the numerator. Because this exponent is negative, it's not supposed to be there. So we have to put it in the denominator, and once we do, it turns to positive. Next is power of a power. So what happens when they're right next to each other? We actually multiply them. So notice we just have one base x, and then we have x raised to the m, and then that whole entire thing is raised to the n power. So what we do is we multiply the two exponents. Our example here, we're going to do x to the fourth raised to the sixth power, so it's going to be 4 times 6, which is going to give us that 24. Again, a lot of little rules. You will be able to use the sheet, so make sure that you have it out. Now, what happens when we have different bases? Notice we have an x and a y. This is product power of a product. So we have different bases, and they're being raised to the m power. So what we do, this is actually an exponent of 1 and an exponent of 1. We multiply m times 1, which is m, and m times 1, which is m again. So everybody gets the exponent of m. So this is x to the m times y to the m. We cannot combine these because they are not the same. We can't go back to use this rule because these are different. So let's look. We have x to the first and y to the first, and those both are raised to the fifth power. So we're going to do 5 times 1 and 5 times 1. So it's going to be x to the fifth, 1 times 5 is 5, and y to the fifth, 1 times 5 is 5. Next, we have power of a quotient. So this has a exponent of 1, and this has an exponent of 1. And the reason why I'm putting my 1s in is because they might have different numbers. So there's no number given here, so remember the 1s like to hide, so we put them in. So here we have division, so power of a quotient, we're dividing. What we do is just like what we did before, where everybody is going to be multiplied by that outside exponent. So this is going to be x, 1 times m is m, and y, 1 times m is m. And notice these both stay in the numerator and denominator right here. So let's look for an example. This is really 2 to the first and 3 to the first. So we're going to multiply. 2 times 1 is 2. 2 times 1 is 2. Now we could keep going to simplify. 2 squared is 4 and 3 squared is 9. Now here's my negative exponent rule down here. I rewrote it as another rule. I didn't want you to get confused up here, so I made sure I included it. I feel like this is a double rule almost. So x to the negative m. So remember, when our exponent has a negative power, it's going to be put in the other spot. So this is in the numerator because this is really over 1. If it has a negative exponent, then it gets moved to the denominator, and now the exponent becomes positive because that's where it's supposed to be. Let's look at 2 examples. X to the negative 7. So since this exponent is negative, it's not supposed to be in the numerator, so we have to move this whole entire thing down to the denominator. So it kind of flips. And what happens if it's in the denominator? 1 over x to the negative 5. Well, it then gets put up and it becomes positive. So this is really over 1. However, when we have it over 1, we usually just take away that division sign and that 1, and we just call it x to the 5th. Okay, 2 more to go. So we have the identity exponent, and that just means x to the first equals x. Remember, I was putting my 1's in, so this is just saying if you don't have an exponent here, you know to put the 1 in. So x to the first is x, 8 to the first is 8, 9 to the first is 9. These mean the same thing. It's just that we can write it with the 1, or we don't have to write it with the 1. And then lastly, the zero exponent rule. Any number or variable raised to the power of 0 is always going to equal 1. We just have to make sure that this x will never be 0. So we cannot do 0 to the 0. But any other number besides 0 or variable raised to that 0 power equals 1. So 2 to the 0 equals 1, x to the 0 equals 1, negative 4 in parentheses to the 0 equals 1, so on and so forth. Y to the 0 equals 1, and that's a very, very common rule that you'll see. So this has been a review of the laws of exponents. I hope it helped.